Mike, thanks for sitting down with me today. I appreciate it.
My pleasure. Thank you for asking and having me.
Mike, I understand one of your areas of expertise is biofortification.
This is true.
We've been talking more and more about it. Can you explain a little bit about the role that biofortification plays in feeding the world?
So let me at first explain in my own words what the concept of biofortification actually is. So in theory, it's using genes and alleles to improve the nutritional quality profile of food crops. So to give an example of what we're doing in my research lab is we're improving the provitamin A and vitamin E content of maize grain. And I also have projects to improve cassava for provitamin A content. So the big challenge about biofortification is a lot of the food crops that are eaten in the world, such as rice, potatoes, maize, and cassava, are a great source of calories, carbohydrates, starch, but they have such a low concentration of important nutritional compounds such as, say, provitamin A, vitamin E, zinc, and iron, and iodine, or other B vitamin complexes. So I think now people are realizing that calories is obviously very important, but we need to be thinking more about malnutrition, and that is improving the nutritional content, because there's this concept called hidden hunger, whereas you may be receiving the calories, but you're not getting in other nutritional value that you actually need. So I think it's becoming highlighted a lot more in breeding programs as we try to feed this growing world's population, where in the past, at first it was just breeding for yield. Now we're beginning to be more mindful of also breeding for quality traits as well at the same time.
What trends do we see in biofortification, or focal points maybe is another way of asking?
So I would say what I think most people will have heard of is probably golden rice. And golden rice is very much a hot button topic in the sense it's transgenic, and it really hasn't had an opportunity to impact the world's population that is at risk and who can benefit greatly from it. It just hasn't had the opportunity. So when we think about biofortification and what it can actually offer, when you think about at-risk populations, you should be thinking about, okay, what certain vitamins or other nutritional components are they not getting in their actual diet? And then that should maybe be a focus of breeding programs in that area of the world. But ideally, we don't just want a population to subsist entirely on, say, cassava or maize or rice. We need a diversity of their actual diet, so then you can say bringing in fruits and vegetables, and such as like obviously carrots, great source of provitamin A, kale, as my shirt would say. So those are some things that we should be keeping in mind. Is yes, we should be improving the nutritional value of our key food crops, but at the main we should also be diversifying the foods that we eat. Problems is, such as in countries of sub-Saharan Africa, they may not have the financial resources to maybe purchase meat, fish, and other fruits and vegetables, or perhaps they won't have even access to it.
Right, well, and speaking of that, you're working with a plant that I will be first to admit I'm not familiar with.
Yeah.
Waiuli? Waiuli. I'm not familiar with it at all. And why is that plant so important? And where are you taking it?
So this is just going to be totally different, unrelated to biofortification at all, because Waiuli is used for rubber and latex, and is a desert shrub growing in the Southwest US. And a lot of people may not realize this. Rubber is essential to our economy of our entire world, okay? And right now, there are a lot of clonally propagated rubber trees in Southeast Asia that are at risk from like blights, and they don't have the resistance to prevent from being completely wiped out. So can you think of a world that we live in now without rubber? I cannot either. So this is a way to produce a sustainable domestic source of rubber and latex in the US. And this is essentially also a particular plant species that's almost maybe 1 or 2 generations removed from being a wild species. And we're creating a lot of the genomics tools and resources now so that people can be breeding it now. So there's tire companies such as Bridgestone and Cooper Tires that are beginning to invest heavily in this plant because they see the future as if they want to be able to provide for their own products, i.e. tires for like cars and trucks, they have to have a renewable source. And so this is an alternative to trees that are, say, growing in Asia.
Interesting.
Yep.
Interesting. Well, and to change gears one more time,
yep.
As the chair of the USDA's Plant Breeding Coordinating Committee,
yep.
Why do you think it's important for government officials and policymakers to understand what plant breeders are working on, and then also the techniques and the technology that they're using to do that? Why is that so important?
So I've been, I would say, privileged to, these past few years, and now chair, and then after this meeting I'll be the past chair of the Plant Breeding Coordinating Committee. And it was, I think, a very unique opportunity for me to provide service to the greater plant breeding community in the US with a focus on land grant universities in the US. So it's very much focused on the public side. And even though I can't, present a case to Congress because I can't lobby, okay? But I can answer any questions that come from, say, other groups in the federal government, okay? And this provides us a vehicle for all of us plant breeders to, share and communicate to perhaps people that are the policy makers, and so that they can appreciate the impact that plant breeding is having on the US in terms of providing food and nutritional security, and also helping us, in a sense, prepare ourselves as a country and as a world in the face of climate change. And when you think about climate change, you can think of droughts, heat, and flooding, and fastly evolving pathogens as well. These are things that are ongoing and are always going to be a problem. Like, plant breeders will always have a job, basically. And I just don't think there is a good appreciation, even in the general public or even in the people that create the policies, in that this is such a critical component of the US, and being able to increase the capacity for plant breeding in the US is not only important for the security of the US, but for the entire world.
Big tasks.
Plant breeders have a lot of weight on their shoulders, but at the same time, thankfully we have our entire careers.
Right, exactly. So maybe I'm going to ask you to talk a little bit about some of the new breeding technologies that are being used today, and maybe a little bit around what's at stake if they become as regulated as GMOs, and what's your recommendation to those that are reviewing these techniques to determine how they should be handled?
Yeah, that's definitely a tough loaded question. So when we think about a technology such as CRISPR-Cas9 and the type of impact that can have on public plant breeding, is that can offer public plant breeders an opportunity to basically do gene therapy in their breeding programs and be able to quickly, or I should say in a quicker fashion, bring a product to a consumer's table a lot more rapid and using a more precise technology than has ever been performed before in the past 20 plus years. Now, with any new technology, there is always going to be risks. So what I would ask was for anyone that's evaluating this technology is to carefully and objectively evaluate the science. But at the same time, I think one of the major failings that we've had with transgenics is in the early, say, 20 plus years, maybe when transgenics were just being released, is we didn't really involve the public and educate them and bring them in as being part of the process. That's where we failed in maybe the late 80s and the early 90s. And I am at fear that something like that could happen again for such a potentially game-changing technology such as CRISPR-Cas9. And so if the public isn't part of this process, then I'm really frightened that we may fail as plant scientists, but as scientists in general.
Agreed. Well said. Mike, you've received a number of awards. It's clear that you're a leader within the plant breeding sector.
Thank you.
What advice would you have for students as they get ready for a career in plant breeding, or maybe even more importantly, for those people even considering a career in plant breeding?
Yeah, so that's a really tough question, and it causes me to pause and kind of reflect on my, I guess, past years in science. But I think probably one of the most critical pieces of advice I can give to someone is being able to sit down and pause and to ask important biological questions. It really begins with the question. And you can, pressure test that question, look at that question from every angle, and then that is, in a sense, like the crux of your research going forward. And, is that a testable hypothesis? Do I need to revise that hypothesis as I go forward? And then you need to also be thinking about the potential impact of that important biological question that you are asking, not only in the context of your crop that you're doing this in, but in the context of crops or plants in general. And that, I think, is obviously very critical because, the first thing is, obviously, we want to do high quality research. We can't obviously publish in the top journals, but just as long as it's high quality. But I think the key, though, is it all begins with the question that's being asked. And then at the same time, I think you can ask yourself, is this an impactful question? What type of impact will this have in science if I carry out this research project?
Right. You're involved in a number of projects. You got a lot of things going on.
Yeah.
What gets you the most excited now? What gets you out of bed in the morning?
That is a good question. I think one thing I maybe haven't learned early on, and I guess I'm not entirely like an early career scientist as I once was, but I think I haven't said no a lot of times, right? Because science is just so fun, and you just want to ask these questions, and you want to have new challenges and new projects and new colleagues, and that's always fun. But when I think about my passion and what gets me out of bed is really feeding the world highly nutritious food. And that's where I think plant breeders can have a tremendous amount of impact on humanity. And that is where my passion lies.
Nice. Well said, Mike.
Thank you.
Thanks very much for sitting down with me. I appreciate it a lot.
Pleasure.